Okay, so where we started? So we put them on the radiosity cache. In the code, that's considered a method called diffuse sliding. I'm going to skip over the code. But the idea is we have multiple resolutions of it. So even though we shade it at full resolution, we'll actually store the indirect diffuse at full resolution, maybe half resolution, maybe even a coarser resolution. So we call it a multi-resolution radiosity cache. What that means is whenever we shoot another ray, we can decide how detailed it needs to be, and then pick from a coarser or finer cache. So here's an example of how that would work in practice. So that's the direct learning. When you're doing indirect, you might shoot all of these different rays. We can use the ray angle at first to decide which level of the radiosity cache we use. So if we do that, note how on the right, where the angle between rays are larger, we can use a higher level of the cache. So this is sort of how we can make color bleeding really fast, and then we just shade, we just pick a couple points from that. Indirect specular, we don't have a radiosity cache, so usually we have to trace a ray from the eye in the reflection vector towards the light source. And we often have to trace many rays, but fortunately we can consider the material properties to figure out which directions are important. And anyway, we shade those points. So the main way you make your renders faster with ray tracing is a technique called importance sampling. Importance sampling means you only shoot rays where they matter. You have to kind of figure out which rays are important, which are not. Shoot more rays where it's important, fewer where it's not. But that means more rays along your reflection vectors, more rays towards the bright spots, and less rays in solid shadows. You know, if you're always in shadow, you're going to get a lot. So here's an example of how that would work. So first thing that happens when you're doing physically based shading, let's say we're shading that point there. I've created a little line that says that's up where the normal of that point is, and we can consider those other vectors to be pointing towards the light sources. What we have to do, because it's physically based, these are not point lights, we turn those into many little light sources. So every area light you have has to be considered a bunch of small point sources. That's what we call light samples. So in this case, it looks like we have 8 light samples by default in each light, or 6 maybe. Then what we do is we have to trace a ray towards each light source. And if we do that, we can see a couple rays hit objects, meaning those point lights are in shadow. A couple rays don't. The rays that are blocked essentially darken the light.